Welcome back to Linux Fundamentals, Module 007, Text Editors and Linux Processes. In Module 006, you mastered 5 operations with CP and MV. You decoded ls-l output. You worked with environment variables and wildcards, and learned the 3 quoting styles, the LPI exam test. Today, we add 3 more essential layers. First, editing files directly on a server because you cannot open Notepad or VS Code on a remote machine in Frankfurt or Cape Town. You SSH in and you need an editor that lives in the terminal. Second, understanding processes. What is running, how to monitor it, and how to stop things that go wrong. Third, system logging, where Linux writes the truth when things break. Pace yourself. Doing your commands to memorize and a couple of habits that take a week to feel natural. If you are following along, SSH into your EC2 instance now before we get started. Here's a quick recap of Module 006 before we dive in. 5 things you should already own. DP copies files. Use -r for directories. MV moves and renames in one verb. ls-l shows 7 columns. Type, permissions, honor, group, size, date, and name. Environment variables, home, user, path, store system settings. Create your own with name equal value. And export to share them. Export is an important keyword when you want to share your variables to child processes. Wildcard star and question mark select many files at once. 3 quoting styles. Double quotes expand variables. Single quotes are literal. / escape one character to the right. Today we move beyond who and what to how you actually do things on the server. Editing config files is at the heart of every sysadmin's or cloud engineer's job. And understanding processes means understanding what is actually running on the machine you have just configured. The permissions and file foundation for Module 006 is incomplete without today's editor and process layer. Here are the objectives of this model. By the end of this model, you will edit files using Nano, a beginner-friendly text editor, and VI, which is essential and universal. You explain what a Linux process is and identify its PID, that's the process ID. You are able to use PS and top to monitor what's running. Run processes in the background with ampersand and stop them with kill. You will be able to read system logs, dmesg, journalctl. You also use the free-h and the df-h to check memory and disk usage. Note the new objectives on system logging, syslog, dmesg, and journalctl are LPI essential exam topics you should take note of. Part 1. Text editors, Nano and V. The 2 editors every Linux user must know. Nano is the friendly one. VI is the universal one. We'll cover Nano first because it's beginner safe, then VI because it's on every server that you ever touch. Why you need a terminal text editor? On a real cloud server, an AWS EC2 instance, a DigitalOcean droplet, or a bare metal box in Lagos data center, there is no graphical user interface, no Notepad, no VS Code window. When you SSH into edit a config file like /etc/hostname or /etc/games.com or your own home bash RC file, you must use a terminal-based editor. 2 dominate in the field of Linux. Nano is simple, beginner, and friendly. Shortcuts are always shown down on the right of the screen. I'm going to see that. You just need to type with no mods or no surprises. Like sending an SMS on your phone. It is best for quick edits. Beginners simply configure changes. VI or Vim is powerful, available on literally every Linux system ever shipped. It has 2 modes, the command mode and the insert mode. This kind of confuse beginners, but it requires constant practice to understand. It's essential when Nano isn't installed. It is often on every minimal cloud image. Best for complex editing, scripts, emergency rescue when Nano is missing. Now, can you remember the 2 editors we have just covered? for sure nano and vi or vim. Why it is matter in real life? When AWS gives you a stripped down Linux image, vi is the only init editor on it. Knowing vi survival commands is the difference between fixing a broken server and rebooting it. Nano, the beginner-friendly editor. The workflow is very dead simple. You just need to open the file with a nano file name. You type your text, you don't need any modes, you don't have any surprises. You normally save with Ctrl+O, that is pressing the Control key and then pressing the O key while the Control is still held down, right? So the O stands for write out. Press Enter to confirm the file name. You exit by pressing and holding the Control key down and then hitting the X key on your keyboard. If you exit without saving, Nano asks Save Modified Buffer. You normally hit the Y key to save. N is to discard, which is for no. Control C is to cancel. The caret symbol at the bottom of the Nano screen means the Control key. So caret O means Control O, caret X means Control X. Time for a very quick demo. So the best way to understand how Nano works is by actually going to the terminal. So I'm going to start back my putty, and let's try to create a file here. So basically, what I'm just going to do is I'm just going to do nano, and let me say hello. Hello, I mean to say txt. Hello txt. I just type nano hello txt and I hit enter. The window comes in where I'm able to type my text. Now let's first try to understand the screen. You see the cursor is showing at the top here, so you can start typing at the top left, right? Then you see the caret G here means if you hit caret G, you get some help. Caret X means you exit. Caret here means control. So if I press the control key plus X, that means exit. If I press control key and while holding it down, press O, it means write out, which is for saving. Control plus R means read file. You can see other more commands that you can use with caret. But let's do a basic. I've opened the file. Let me try to just write something very basic. For example, if I just type hello on cloud, let's say this is all I wanted, right? How do I save this? I press Control key and then O. That's the control or the write out here. So Control O will ask me write to file hello text. All I need to do is I can just hit enter and then it means it has saved, right? If I want to exit, I just press Ctrl X. It has exited. So with those steps, basically, I've opened a file called hello.txt and I've written into it hello WirfonCloud. Now, if I want to read the file, I can just go back nano hello txt. Let's see, this file will open and I'll see that it already contains the text hello WirfonCloud, right? So that's very easy. I can do Ctrl X again. I've exit. I can use the cat key, the cat command, not key, the cat command. Remember, the cat is to looking for when you want to look at contents of a file. If I do hello, if I do cat hello.txt, I see that that file has that content hello from cloud. And if I really want to just be doing a little more than less is a much more sophisticated command that is able to read a larger file. But let's say I want to read the file with less. You see, it will show me hello from cloud. That's the information they are seeing that is available in that file. And to quit, when I'm using less, I just have to type quit, right? Quit. So that is basically how to write text when you are using Nano. If you try to some sort of troubleshooting, if you see file is unwritable at the bottom, it could be that directory has no write permission. So maybe you don't have the permissions to write. We are going to work on permissions in the very next model, and you see how important that is. Now, when you are changing your server host name, you need to use the sudo command. So sudo, remember, is when you want to borrow privileges, root privileges or administrative privileges, there's a file called /etc/hostname, and this file actually contains, let's say, contains the hostname of your server. If I want to change that, I'll need to use the sudo command. Why would I use the sudo command? Because the /etc/hostname is actually requires administrative privileges, right? You need administrative privileges to be able to edit the file /etc/hostname. So you need to use the sudo command to open that file. I'll advise that you should not change your server host name now, because normally when you change that, you need to reboot your server for that to happen, for that to effect on the server. We are going to do that when we are coming almost at the end of the course itself. So when you are learning how to reboot your servers, and when you reboot, also your IP address is going to change, and what will happen is you need to reconfigure to use your putting app. But once you have done it once, you see that it's very easy. So that was it about looking on how Nano works. Let's proceed. And here we have the VI or Vim, right? VI and Vim, these are the universal editor. VI is on every Linux system. Vim is the VI improved version. It's the same workflow, more features. Most servers have VI, and at times you need to install Vim. The thing that confuses beginners when they are trying to use VI or Vim is the two modes. When you are using the VI or Vim editor, there are two modes that you have to take care of. There's the command mode. When you open VI, you are normally here. Every keystroke is a command, not text. Press I and do not type I. Once you press the I key, you switch into the insert mode. When you press double D, you delete the current line. This is where beginners panic. Insert mode, press I, and you are now typing text normally. You will see insert at the bottom of the screen. Press escape and you go back to command mode. The golden rule: if you are confused, press escape. It always takes you to the command mode, the safe zone. The survival kit is to memorize this. I equal to start typing, the insert mode. Escape is the stop typing, command mode. DT is equivalent to delete current line. YY is equivalent to copy the current line, then P to paste. U is equivalent to undo, and colon double slash. Colon WQ is save and quit. The colon Q with exclamation sign is to quit without saving. The emergency exit is just to have the double column W and save, stay in the file. Now we are going to do a quick demo again, and this will help you have a good understanding of how VI or Vim works, right? So I'm going to go back to the terminal, and I'm going to do Ctrl+L to clear. I'm going to press Ctrl+E to go to the end here, and then just do this. And what we're going to do is, let's open a file. Let's just do vi hello underscore vi.txt, right? This is different from the one that we had with nano. So hello, vi hello underscore vi.txt. So if I hit enter, what happens is I always land in the command mode. Here I cannot type anything. If I try to type anything, it will be thinking I'm trying to give commands. The only way to start typing is, the first thing I do is I press the I on the keyboard. If you notice, once I press I, it changed to insert. This means now I can start typing. If I want to go back to the command mode, I press the escape key. And if you notice at the bottom of the screen, I don't have insert being displayed. So this is the command mode of VI, and I cannot basically type. I can only read. So again, I press the I, it gives me the possibility to start typing. So I'm going to type something simple, like hello from VI, text editor, right? After finish typing, the question is, how do I save? To save, you need to go back to the command mode. How do you go to the command mode? I press the escape key. When I press the escape key, insert disappears from the bottom. So this means I'm now in the command mode. In the command mode, how do I save and quit? I press the column. You see column appears at the bottom. I go to W, that is for write, and Q for quit. And then I press exclamation sign. That's basically all I do. The column comes, W is for write, Q is for quit, and I press it, and then the exclamation mark. If I hit enter, all of that is written into the file, and then I'm able to escape the file also, have back my prompt. So what happens if I want to look at the content of this file? I can also do cat hello was underscore vi, right, .txt. If I do cat on that file, what do I get? Hello from vi text editor. That's what I got. I can also use vi to view that file. Why not? So I can do vi hello underscore vi.txt. If I open that, it opens and shows that it's a file that's open and it already has that content. And again, there is no insert at the bottom. This means I'm present in the command mode. So if I want to change a few things on the file, I can press the I. I is for insert. You know, at least I have insert at the bottom. I can go ahead and add another line. This is Linux demo for VI, right? And then again, if I want to save and quit, I'm going to press escape on the keyboard. Once I have insert here, I cannot go to the command mode. I have to press escape so that there's no insert at the bottom here. Then I do colon, W for write, Q for quit, and then exclamation mark. I hit enter. That is save also. Let's look back in the file using the cat command and see what we have got. It has the 2 lines, right? And if I do an ls here, then the ls will show the files that I have. There's the hello underscore vi.txt. So it's also a very important, it is a basic and a very important editor that every Linux engineer should have. So the panic most beginners have is when they are present in the command mode and when they are present in the insert mode. You just need to be calm, and with a few practice, you realize that it's a very nice tool to use. When you normally SSH into a fresh Amazon Linux EC2 instance, VI is the only editor pre-installed. It is a survival kit that will save you in one of the ships. Now let's go back to slides and move on. Part 2, Linux processes. Move from editing files to understanding what's running on the machine. Every command you have ever typed has spawned a process. Today, we name them, list them, and monitor them. What is a Linux process? Every running program, your shell, your editor, the web server, and we're going to see that in Module 9, the database as well, is a process. When you type a command, the kernel creates a process to execute it. If you recall from one of the last sessions, we said that when you type a command, the shell takes it, hand it over to the kernel so that it can be executed. So the kernel creates a process to execute that command you have typed. Every process gets a unique PID, which is the process ID. It's a number from 1 upwards. The very first process is systemd, or in older systems, init, always PID 1. Systemd starts at boot and is the parent of every other process. Parent processes create child processes. When you run bash, and inside bash you run ls, bash is the parent, ls is the child. Process states the exam asks about running, actively using CPU. That is one process state. Sleeping, waiting for input, or I/O. Most processes spend most of their time sleeping. Stopped, paused by the user. This is usually done using the Ctrl and Z key. Zombie, finish, but the parent hasn't collected the exit status yet. dead, terminated and cleaned up. Factory analogy. Processes are workers in a factory. Each worker has a badge, which is the PID. The factory manager is the system D process. That's the process with PID 1, who hires everyone. Workers can be in running state, which means they are active, or they can be in sleeping state. That means they are waiting for parts. They can be stopped, which means they are on break, or have clocked out, and that means they are dead. A zombie is a worker who finished their shift, but whose time sheet hasn't been filled yet. In the cloud context, on a fresh EC2 instance, dozens of processes run at boot. SSHD waiting for your connection, system D managing services, cloud init configuring the instance, networking demos, log collectors. Understanding processes equals to understanding your server. PS, process status, a snapshot of what's running right now. Plain PS shows only the processes attached to your current terminal, usually just bash and PS itself. PS AUX is the most commonly typed variant. It shows all processes from all users, with user, PID, CPU in percentage, memory in percentage, and the command name. The A is all users, U is user format, X is include processes without a terminal. PS with the option -E and F is another popular form. It is similar info, but with a full command path. It is useful for seeing how a service was started. The killer combination PSAUX pipe grep name of service, that is how you check whether a service is running. PSAUX pipe grep SSHD, for example, you see in one or more lines, SSD is alive. Now, time for a very quick demo. So let me go back to the prompt. And what we are going to do is we're just going to run PS, and you see that it just shows the PS itself as well as bash that's running, right? So bash and PS itself, that's the only thing that is running. Now, if I decide to do PS AUX, remember this will show all processes from all users with the user process ID, CPU in percentage, and memory in percentage, and the command name itself. So if you look carefully, I see the user, the PID, percentage, and CPU in percentage, memory in percentage, and the command that is in charge of the process that is running. The command is always at the end here. Okay, so that's how PS AUX will look like. But what happens if I only want to see those at the top, the first 10 ones? We have seen this quite a couple of times. I pipe that and I say head, and I want to see the first 10 of them, right? I can do -n and I do 10. I hit enter, will show me just the first 10. And again, similarly, try this again. You may just be interested with the last 10. So that will be tail -n, and it will show me the last 10 processes, right? Now, if I want to check if a particular process is running, let's say SSH, how do I do that? Right? I'm going to clear. I want to run PSAUX, but what I'm interested in is SSHD. So I'm going to grep for SSHD in that output. So if you notice, so I'm running, the output will come out, and all that output will be sent into grep, and grep is trying to match a certain pattern. So it's looking for anything that has SSHD. So I can see the SSHD daemon is running. That's a process that is able to accept each when I'm trying to sign in by PuTTY, because PuTTY uses SSH, right? Now, here's some troubleshooting tip. If you run and you get 2 lines, and when you are doing the grep, one is always normally for the actual process, and one is for the grep command itself. Grep normally matches its own command line, right? So that's something you should keep in mind. It's a common artifact, and it's not just a bug. you should always use ps aux pipe grep sshd with brackets to filter out the grep itself. In a real-life scenario, your manager at a particular fintech may say the API is down. You have to check if the app process is alive. So if your manager tells you the API is down, the question that should come into your mind, what is the name of the service that the API is using to run? Once you know the name, you can check if it is up and alive. So I can do ps aux, and then I have to pipe that. Let's say the name of the app was my app, right? So I'll just do ps aux, and then I'll click for my app. Let's say my app was in charge of the API that was working. So if the API is down, I want to check if the process is. So if I do this, like in this case, there's no process called my app, so I just have the output here, which is just the command itself that I've just typed, right? But just give you an idea, if your manager tells you the API is down, the question should be, what is the name of the process behind the API? Once you know the name of the process, and it will always be in some records somewhere, right? Then you can then come and check if it is up. Like here, SSD is up. If SSD was down, if I could not get SSHD down, there's no way I'll be able to log in using PuTTY, because PuTTY needs SSHD to be up and running, right? So that is a quick demo. So let's go back to the slide and move on. Now, top is a real-time process monitor. It's a live dashboard of your system. It refreshes normally every few seconds and shows CPU usage at the top, memory usage below that, and a sorted list of all active processes that are running. And this is always sorted by CPU consumption. It is the Linux equivalent of the Windows Task Manager, right? You normally press Q to quit each time you are finished working with top, right? If you want to sort the different processes, you can type P, it will sort by CPU, which is the default already. If you press capital M letter on your keyboard, it will sort by memory. And again, lowercase k will let you kill a process by typing its PID. So after looking at the entire top output, and if you want to kill a particular process using the PID, you use k. We're going to come with killing a process shortly. Lowercase q will always quit. So related system monitoring commands that you have to know are things like -h, which shows memory usage. We have seen that. And then if you are looking for if you're also looking for this usage, right, df-h will show you this and space per partition, and this is always important because your server can crash if a particular disk is full. Now, let's do a quick demo here before we consume more material. So I'm going to just type top. This is the top command. You see it's displaying CPU usage, memory usage, total, how much is free, how much is used, swap. We have seen this earlier as well. This is the PID of each service. There are many services that are running. The user that started the process, right? Remember, PID1 is systemd. It is a process that starts when the server is running, right? So it's starting as one, and every other process is a child process of systemd, right? So that is how the output looks like. If you want to notice, there is percentage of CPU consumption in CPU. This is shown in percentage. Memory consumption is shown also here in percentage. And if I press, let's say capital M, can sort depending on how much memory is being used. So you see, start now from the highest memory, it's coming down. I did press capital M, and if I switch states like that. I can also do another way that you can want to sort is if you use P. right? If you want to sort by CPU usage, so if I press again Control and press P, now it's sorting by CPU usage, the higher, right? So that is how. This is a very not so active server because we're using it just for teaching. But if you use this in a very live server that is busy, you see some of the changes. Right now, we have seen. If I want to leave this window, you press Cure. Cure would go quit, so I can go ahead and clear. We have seen the free -h command. We saw that earlier. df -h is when you want to check for disk usage, right? You want to check how much space is free on your disk. Let's say we have here a disk, the size that we had is 6.7 gigabit. We have used 3.0 gigabit, right? And available is 3.7, right? So if you want to check, since we don't have like Windows where you can see how much this usage is going, to do that with Linux, you use the df -h. And then you look for how much space is actually being consumed, right? So moving on, part 3, managing processes and reading logs. Now you can see what's running. The third part of this model is about controlling what's running and reading what the system says about itself. Background, foreground, killing processes. The ampersand at the end of a command runs it in the background. Sleep 300, where sleep is the command, and then ampersand at the end gives you back the prompt immediately. And then sleep runs invisibly. The terminal shows 1 in square brackets and, for example, 5, 6, 7, 8. The 1 there indicates the job number and the process ID is 5, 6, 7, 8. When you use the command jobs, it lists all your background jobs. If you use FG, which is foreground, %1 will bring the job that is running in the background to the foreground. And in this case, the job with number 1. If you press Ctrl and the Z on your keyboard, it will pause the currently running foreground process and drops it into the background as a stopped job. BG, which is background, %1, resumes a stop job in the background. Killing a process. Kill PID sends a polite signal to terminate that process. So the SIGTERM there is a short form of signal terminate, which is just simply saying, please stop this process. Most processes will respect it by closing files cleanly and exiting. But there are some cases where you try to use the kill and it doesn't work. Then you use the -9 option. So kill -9 with the PID ID sends the signal kill. The kernel terminates the process immediately. No question is asked. So you use the kill -9 only when the kill alone doesn't work. Kill all name kills every process matching the name. Kill all Gings, for example, will kill every Gings worker. Now it's time for us to do a quick demo so that this makes lots of sense to you. So let me go ahead and clear the screen. And let's start with using the sleep here is a command that basically is counting, it runs for 300 seconds and then it stops, right? So the sleep here is just asking, you can ask this to run for 300 seconds and stop. So if I do kill and I have the ampersand at the end, and if I hit enter, that command will be running in the background, right? So you see it starts with a 1 here in square brackets. It means that there's a background process listed as job 1, and every process always have a process ID. So this command is running with 137239 as the process ID. If I want to see all the jobs that are running in the background, I can always type jobs, and you see it will tell me that there's a job called 1. That job is running and it is been activated by the command sleep 300 with the ampersand at the end, which is just what we did, right? What happens if I don't use the ampersand? If I just do sleep, let me do another one, sleep 20, and if I hit enter, you notice that I don't get my command prompt back. So if you want a command or a process to execute in the background, you will always terminate it with the ampersand. Because you notice now that I can't get my command prompt back. So the only thing I have to do, we have seen this, I have to press Ctrl+C, right? It was after 20 seconds, and the good thing is that also finished, right? So just before I press Ctrl+C, 20 seconds had passed, and then the command did finish. If you want to see that again, let me do sleep with a small number. So let's just say sleep 3 seconds, and if I hit enter, what will happen is after 3 seconds, I'll get my command prompt back, as you can see, right? So that is how you can activate, use the ampersand to send jobs into the background. So again, I'm going to do jobs. I want to see if that command is still running. You see, it was 300 seconds, so it's going to take a long time. That is still running. Now, let me kill that process, right? I want to stop this process from running. If you see, I have the process ID here, but what happens if I want to kill it using the job number? So I can do kill percentage. So I can use kill and use the percentage here to reference to the job number 1. And if I just do that, that is enough. So it's going to kill the job by the job number. The job number is 1. So kill percentage 1. If I hit enter, as you notice, it says 1 is terminated. The command is no longer running. If I were to run jobs, I'll see that there is no longer any job running, right? So as I mentioned earlier on, if you happen to try to kill a job with kill and it doesn't work, you use the -9 option. So kill -9, for example, and if I were to, like in this case, I knew the process ID was this. So if I were to use the process ID, this already gone, but I'm just showing you how you could have done that using the process ID. So this is more of like a forceful kill. You wanted to kill it gently, it did not work, which kill here again is just you wanted to stop the process. At times when you are stopping a process, it refuses to stop. Then if you want to forcefully stop the process, you use kill with the 9 option, right? So it could happen that you are doing a deployment and the script is stuck and it is consuming 100% of the CPU in a production server. That's not a good way to go. So what do? You look for the process ID. There are many ways you could look for the process ID. One of it is we have seen VSAUX. You can run that command. You see exactly what is the process ID. And once you get the process ID, you then go ahead and use the kill -9. And then with the process ID that you have seen, you'll be able to kill it, right? So this is a very practical way that you can use that command in a real life situation. So let's go back to our slides and look at what's next. System logging and messaging. This is something we have covered, but it's always good to look at it again. So remember, Linux records everything. You remember I talked about someone being at the bus station and recording every bus coming and leaving. Now, knowing where to look when things break is what separates a junior from a senior admin. And I've repeated it a couple of times. Senior at times does not have to do with the number of years. It has to do with how much you have been practicing. If you have spent 2-3 years in Linux and you are not practicing enough, someone can spend 1 year and practice really enough, and he can be regarded as a senior Linux administrator because of the skills they have done. So practice is the key. There are 4 log files to memorize. The /var/log and /syslog is the main system log on Ubuntu and Debian. General events, errors, services starting and stopping, you can find it on this file. /var/log/messages is the same rule on Red Hat, Rocky, and Amazon Linux. The distro split here, you have the /var/log/auth.log, which is where authentication events and SSH logins happen. The sudo usage, the password changes. Security is always critical, and the first file to read after any suspicious event is the /var/log/auth.log. right? Then the /var/log/kern.log is kernel messages. So if you want to look at hardware events, driver issues, boot time problems, go to the /var/log/kern.log. Now, two commands that don't read files directly. The dmesg, it prints the kernel's ring buffer, boot and runtime kernel messages. dmesg-t adds human readable timestamps. So if you want to see the output with human readable timestamps, add the minus, the T option, capital T. journalctl reads the system D journal, modern unified log. journalctl-xe shows recent errors with extra explanations. journalctl-u sshd shows logs for specific service. Now, think of a hospital chart analogy. /var/log is the patient's medical record. This log is the general doctor's note. auth.log is the visitor sign-in sheet. kernel.log is the equipment status report. dmesg is a machine's own diagnostic printout, while journalctl is a digital record system that replaces all the paper. In the LPR exam, it's important to know all 4 files and both commands that are used to look at them. So let's go back to our demo again. I've covered this a couple of times, but let's go back here. So I'm going to go ahead and do, if I want to look at the very tail end, I'm just going to do +20 because this works as well. So again, the tail will show me the last 20 lines, right? So that has to be tail. It's the L there. This happens. Tail-20. So using the tail command, I can see the last 20 lines, right? Now, if I want to access this /var, let's see if I do tail here, /var /log /auth.log, right? Without the option bb -20, I'm going to get just the 10 lines. So I'm not going to use the option, but notice when I hit that, I'm able to get just the last 10 entries. Take note that in some system, if you try to access this file, you may get an error and you may require to use the sudo. So in some systems, just depending, you may require that if you try to access it, it may say permission error. So what you can then do is just use sudo in front of it, right? Because it needs sudo. Now, the dmesg, right? dmesg here, I can pipe that so that we see just the last 5 lines, for example. Let me say so, right? Now this is a good example. I try to read that it says operation not permitted. So it means I require a sudo command here. So when you have permissions issue, try to use the sudo in front, and now that works. So I'm happy this was able to come up here. So if you try to use a command and it shows operation not permitted, then it's very likely that you need the sudo, which is borrowing administrative privileges just for this command. And if I pass that through, so in sudo dmesg and pipe that through tail -5, it will give me the last 5 lines, right? So the other one is, what about journalctl? And if I pipe that tail -10, for example, as the output, I can see the last 10 outputs of the journalctl, right? So why does this really matter in real life? The customer can say their login failed at 2 a.m. All you need to do is open /var/log/auth.log and grep for the failed password, match this timestamp, and that's how you investigate every security incident. Right? So these are commands that you can actually use in real life. Now let's go back to our slides and continue. So what are the key takeaways of model 7? Because we have basically wrapped up this model. Now, make sure that you actually look at each of the key points here on the slide and try to remember them, right? We have talked about nano. When you want to open a file, what you type, Ctrl+O is to save, Ctrl+X is to exit. It's beginner friendly. It does not have mode. BI is universal and it has the command mode as well as the insert mode. You press the I to get into the insert mode, which is where you start typing, and the escape key will always take you back to the command mode. How do you save? Right? You use the colon and then WQ with to save and quit, and remember the exclamation mark after. Now, emergency exit, you don't want to change anything. You just have the colon, Q, and then exclamation mark. Every running program is a process, and in every running program has a unique process ID. System D is always process ID 1. Now, PSAUX shows you all processes. Top is the live monitor. P-H is for RAM. DF-H is when you want to look at disk usage. Ampersand at the end of a command runs it in the background, while kill pit is gracefully killing a process, or again, stops the process. Kill -9 is when with the pit ID is forcefully killing a process, and that should be used when kill with the process ID doesn't work. System logs /var/log/syslog is the general events on Ubuntu. Auth.log hosts logins, kern.log hosts hardware. dmesg shows kernel messages, journalctl-xe shows recent system errors. Before moving, ask yourself, how do you exit BI without saving? The answer, of course, is :Q exclamation mark. That is the one command every beginner actually needs to know. Okay? Now, hands-on labs, make sure you complete them. Look at the editors. Here we have some practice that you should do. Pause the video and do all the 5 steps by yourself. Type every command. Do not copy and paste, because this takes away you building the muscle, right? Make sure that you complete the lab, and if you have any questions, make sure that you also bring that up in our Discord channel or during our live sessions. Do not forget Kimo, your AI learning assistant that is available here in the course. If anything from today is still unclear, make sure that you look into Kimo and ask the questions as we have done in other sessions. Ask Kimo to explain it in a different way or quiz you on it. That brings us to the end of Module 7, but before we move on, complete all the remaining module activities, walk through the hands-on labs, answer the knowledge check questions, and attempt the certification style questions. Take your time, because they are there to make sure the concepts have landed, not just being heard. And do not forget, again, using Kimo when you are challenged. In Module 8, we'll cover user management and 5 permissions, user add, pass WD, groups, change mode, and change on. These are the commands that control who can do what on every Linux server you ever manage. So make sure to bring your EC2 instance, and looking forward to seeing you all again. Very Vedfei, Morakoze, Asante Sana, Medesa. See you in Module 8.